Hi everyone, welcome back. Let's extend our discussion of externality by considering the case of a hypothetical steel plant, which I'll assume exists in an area where it's surrounded by a very large number of residential neighbors. Here's a schematic picture of the steel plant in which I've represented the plant itself as an empty box. Here I'll make it look a little bit more like a steel plant by putting a smokestack on it, and we'll assume that some smoke is coming out of the smokestack. But as you can see in the picture, on the right-hand side, the steel plant produces, at least at this moment, a single output, which we'll call steel, and it produces this output by combining what we'll call the ordinary inputs to production inside the factory building in order to make the steel. That is, the plant buys land and labor and raw materials like iron ore. It buys the skill of managers. It buys a whole range of other kinds of inputs. And finally, it buys the input that I call willingness to take risk, and that is what is sometimes called capital. That is, people invest an enormous amount of money building the plant and stocking it with heavy, expensive equipment. This has to be done before any steel can be produced, and therefore it's a risky venture. Somebody has to take that risk. In capitalist economies, those are typically the owners of the firm, and their input is their willingness to take risk. All of the owners of ordinary inputs are paid for the cost of their inputs as they are sacrificed by the original owners and used by the steel plant to make steel. And the steel plant pays for all of these inputs in ordinary markets, characterized by free exchange between the owners of the inputs and the steel plant itself. If input and output markets are competitive, then this will result in a particular result, a particular outcome in terms of the amount of the ordinary inputs that are used and the amount of steel that is produced. What do we mean by markets for steel and for the inputs being competitive? Well, we mean, first of all, that there are many buyers and sellers of identical goods. So, for example, in the market for steel, we'll assume that there are many, many different people who want to buy steel, and there are many, many people who want to sell steel, and moreover, that all of the steel that is being sold by all of the competing steel plants is identical, so that any buyer of steel can distinguish between the different sellers of steel, not on the basis of differences in the steel they're producing, because we'll assume here that there are none, but only in terms of the price at which that individual plant is offering to sell the steel. Similarly, on the other side, the steel plant faces many competing buyers for the steel. From the steel plant's point of view, all of the buyers are identical, except for the amount of money that they're waiving at the steel plant in order to win the custom, as it were, of the steel plant itself. So the first element of competitive markets is that there are many buyers and sellers, each of them trading in an identical good. There are also, we'll assume, low transactions costs, so it's easy for buyers and sellers to meet up with one another, negotiate the terms of trade, and transfer goods after the exchange has been agreed upon. If all of these conditions obtain, then the price of every input and of the steel output will be driven to a single competitive price at which every subsequent transfer is made. So, for example, if one of the steel plants is trying to sell its steel at a price higher than other steel plants are able to meet, then those other steel plants will offer the steel at a lower price, and as a result, customers will abandon the first steel producer with his high price and come to the second steel producer with their lower price. This will force the first steel producer to lower his price as well, and this process will continue until the price at which every steel seller is selling steel is driven down to the same value. Indeed, it's driven down under conditions of competition to the cost of making that unit of steel itself. If markets are competitive and all of these conditions obtain, then the dealings between the ordinary input owners and the steel plant will result in a number of different outcomes. First of them will be that input owners will be fully compensated for their contribution to steel production. So, for example, the owners of labor, workers, trade an hour of labor in exchange for a wage. The trading away of the hour of labor, their willingness to work for that hour, imposes a cost upon them. Presumably, they'd rather be lying around or perhaps even doing a different kind of work if they could. And so it does, in fact, impose a cost upon them to take an hour of their time and use it to help produce steel rather than to put it to some other use. But the laborers do not make this contribution out of love or patriotism. They're fully compensated for it by the payment of their wage. When I say fully compensated, they're paid the competitive wage for their labor, which means that if they got a better offer, that is, if there were a higher salary, they would go and take the job that's paying the higher salary. If we assume that they would do that and they remain working at the steel plant, then we assume that the steel plant is the best opportunity that they have, the most money that they can earn for that hour of labor, and therefore when they sacrifice it to the steel company and the steel company pays that wage, then the input owners can be said to be fully compensated for their contribution to steel production. And what's true of the laborers is of course true of the owners of all of the other inputs, as long as those inputs too are sold in competitive markets. Secondly, the plant itself buys only those inputs that are more valuable to it than to the owners of those inputs or to other people who might buy the inputs instead of the steel plant. How does the plant determine how valuable those inputs are to it? Well, it consults the output price, that is, the price that it can get for the production of steel, and then it knows how much revenue it can bring in for the production of each unit of steel. It can then determine how much it has to pay for each of those inputs and then compare whether or not the amount it has to pay in order to purchase those inputs will or will not be made up as part of the price that the firm receives for the sale of the output. If the firm decides that the unit of labor, for example, is more valuable to it for the purposes of making steel than it is to the laborer, him or herself, for whatever other purpose that person might put the hour of labor to, then the plant will buy that hour of labor. But if the plant believes that that extra hour of labor will not, as it were, pay for itself by producing enough extra steel to pay the wage rate for that hour, then the plant will forbear from purchasing that hour of labor because that hour of labor is worth more to the laborer, for whatever purpose the laborer wants to put it, than it is to the steel plant, which would put it to use in the production of steel. So again, resources in competition move to their highest valuing owners, and the plant will only buy those input resources for which it is the highest valuing owner. Third, the exchange mechanism thus allocates an efficient amount of every input to steel production. As I've just said, free exchange moves all input resources from lower valuing owners to higher valuing owners. So every unit of every input resource that is more valuable to the steel plant for the purpose of making steel than it is to its previous owners for some other purpose will, through the exchange system, gravitate from those lower valuing original owners to the higher valuing steel plant. As a result, the steel plant will use an efficient amount of each input in the production of steel. And finally, the plant will itself produce and sell an efficient amount of steel as a result of the earlier 3 points. That is, if markets are working well, if everyone is perfectly informed about their benefits and the costs of the various alternatives that face them, if transactions are easy, then the plant will only produce those units of steel which are able, as I put it, to pay for themselves. That is, the plant will only produce units of steel such that the value of those units of steel in the output market, when those units of steel are sold to customers, exceed the sum of all of the costs that have had to be suffered by all of the previous resource owners in order to produce that unit of steel. So each unit of steel, as it were, has two numbers associated with it. That is the value of that unit of steel in the output market, and on the other side, the total amount of cost that has had to be contributed to the production of that unit of steel by all of the previous owners of inputs. And if the value of the steel in the output market is greater than the cost of all of the inputs that have been used to produce it, the firm will produce and sell that unit of steel. If the relationship is in the other direction and the unit of steel is not worth the value of all the costs that have been incurred in order to produce it, then the firm will, of its own volition, without being told by anybody, simply not produce that unit of steel. In this sense, every unit of steel that is produced pays for itself by producing more value for the consumers of the steel than they have consumed value on the part of the previous input owners who have lost their inputs in order to help produce the steel. All well and good. Now let's introduce a complication to the problem. Again, let's return to our schematic picture of the steel plant. Let me put the smokestack back in. Let me put some more smoke in the air. And now we'll assume that the steel plant has a second output that it has to produce, because it has no technological alternative, at the same time that it produces steel. So let's assume that in order to produce steel, the firm has to toss smoke into the air, and the smoke contains a lot of chemicals and other particulate matter which people breathe and which makes them ill. Let's call this stuff that comes out in the smoke that people breathe and make them ill crud. Okay. So for the steel plant, steel and crud are what economists call joint outputs of the production process. I'll assume that if the firm makes steel, it must make a certain amount of crud along with the steel. We'll assume that the firm has done the very best it can to reduce the emissions of dangerous crud into the air, but we'll also assume that there's an irreducible amount of crud that has to continue to be produced and thus breathed by the neighbors of the plant as long as steel is being made. So, again, there are two products being made: steel, which people value as a positive good, and crud, which people value as a bad. That is to say, when the crud is produced, people will breathe the crud, and people will suffer costs as a result of breathing the crud. I'll assume as well that every person who breathes the crud is affected differently by breathing the crud. This is true of all sorts of unhealthy conditions: smoking cigarettes, breathing polluted air of any sort. What it means is that over a period of time, let's say 100 people will breathe the smoke for several years at a time. All of those people, we'll assume, will suffer some small detriment to their health. But some of those people will suffer a greater detriment to their health, and a few of them will suffer very, very great problems with their health, some of which may not appear or become apparent to anybody for a very long time. So, when people breathe the smoke, some people don't get very sick at all, even if they breathe the smoke for a very long period of time. Some people do get pretty sick, but not so sick as to be completely debilitated. And a third group of people, we'll assume, get very, very sick and therefore bear very large costs in their good health from breathing the smoke. We'll make one other assumption about the breathing of the smoke, and that is different people who are suffering different effects to their health as a result of breathing the smoke will assume also value the loss of good health that they do suffer differently from one another. So if I lose, for example, 18 months off my life from breathing the smoke, I may attach a particular value to those 18 months, which would determine the amount that I'd have to receive in order to trade away those 18 months of my life if I had the opportunity to do so. But you may breathe the smoke, and you may also lose 18 months from your life as a result of breathing the smoke. But there's no reason why you must value those 18 months of shorter life at exactly the same level that I value those 18 months. So if you were offered a sum of money in exchange for the loss of that 18 months of your life, you might well accept a different sum of money, higher or lower, than the sum of money that I would accept in order to compensate me for the loss of precisely the same 18 months of good health, 18 months off of my life. What all of this means is that the good health of the plant's neighbors, not in equal amounts, but taken from every one of the good health of the neighbors of the steel plant, the good health of all of these neighbors is also an essential input to the production of steel. Since steel can't be made without the production of crud, and since the production of crud produces ill effects on people's health, then in fact the good health of the plant's neighbors becomes, just like land, labor, raw materials, management, and the willingness to assume risk, an essential part of the production of steel. The firm can't make steel without buying the ordinary inputs from their previous owners, and it can't make steel without taking some of the good health from every one of its neighbors that live in the area around the plant. What's the problem created by the crud? Here, it's worth taking note of the particular perspective that the economic approach places on the problem, the general problem of pollution, or the more specific problem of the crud produced by the steel plant. Note that the problem is not the production of the crud as such. That is to say, if there were no people living around the plant, and if the plant itself were operated completely by robots, and if nobody were around to see or suffer any ill effects from the smoke at all, then the argument would be that the crud is not a problem at all. It isn't even a problem if it damages the atmosphere as such, because once again, if there were no people around to appreciate the damage being done to the atmosphere, in one way or another, then there would be nobody to complain about the crud being tossed in the air. So the problem, at least from the economic point of view, is not the existence of the crud or even the despoiling of the atmosphere that is produced by tossing the crud into the air. The problem is only the costs that the crud imposes upon living people. I've reduced in this example all of those costs to the good health of the plant's neighbors, but obviously in the real world, crud would introduce other sources of cost or disutility to human beings. All of those sources of cost or disutility to human beings are the problem that the crud creates, and it's only those costs that are the problem. And the costs of the crud are a problem only if, unlike the costs borne by the ordinary input owners, the costs are external. That is, as we saw in the last lecture, the costs created by the crud become a problem only if the steel plant is able to impose those costs and thus to take the good health of its neighbors without compensating them for the loss that they've suffered when the plant takes their good health and uses it to produce steel. Costs do not become a problem until they are uncompensated or external costs, and that will happen in this example if two conditions are met. One of them is, as we saw earlier, that the law has to step in beforehand and place a property right to be free of the costs imposed by the crud initially in the plant's neighbors. As we've seen, external costs are imposed only when the law recognizes a right of the bearer of those costs to be free of them without compensation or consent. So in this example, we'll assume henceforth that the law has already awarded the relevant property right to individual neighbors' good health to those neighbors themselves. Therefore, if the plant were to take that good health without paying for it, the plant would then, in fact, have imposed an external cost on the plant's neighbors. So, an externality relationship first requires the property right to be placed in the bearers of the cost, and secondly, that there be high transactions costs that prevent exchanges between the plant and its neighbors. Here in red, we can see all of the elements that we saw in the last lecture that are mixed together and combined to produce the problem of externality. Property rights, transactions costs, and the costs that are actually imposed by the cost imposing activity. Okay. So the question then becomes, how are the ordinary inputs the extraordinary input of good health allocated to the production of steel? Can there be a market for good health in the same way that there are competitive markets for the ordinary inputs? If there were markets for good health, that is to say, if the steel plant had to negotiate with each of its neighbors over the value of the good health that the plant is going to take from those neighbors and devote to the production of steel, then the rights to those property rights, those rights to good health, would in fact be allocated efficiently. That is, all property rights would gravitate to their highest valuing owners. Free transactions between the owners of good health and the owners of the plant could be expected to produce an efficient taking of good health by the plant in the same way that it produces an efficient taking of labor or an efficient taking of raw materials by all the other owners of the ordinary inputs. Notice that if there were a market for good health, as there is a market for labor or a market for raw materials, then that good health might or might not be used for steel production. It would depend on the relative value of that good health to its previous owners for whatever purpose they would put that good health to, and the value of the good health to the steel plant for the purposes of making steel. If the good health is worth more to the steel plant for making steel than it is to the previous owners for whatever purpose they would put it to, then a transaction will move the right to the good health from the previous owner to the steel plant. But if that relationship is reversed and the good health owner values the good health more than the steel plant values the good health for use in steel production, then the good health owner, the neighbor, is the higher valuing owner, and the property right will stay with that person because the steel plant won't be able to offer enough to pry the right from the good health owner in the first place. Again, notice, in the case where there is a market for good health, that markets typically do not produce the absolute deterrence of the cost imposing activity. That is, the fact that the owners of good health and the neighbors have a right to be compensated for the loss of their good health does not mean that their good health will not be traded away voluntarily in exchange for a payment satisfactory to the neighbor for the use of the good health in the production of steel. Markets, therefore, don't predetermine whether the good health will be used for steel or whether it will be used for other purposes by their original owners. As I've said, that depends on the relative value of the good health to the steel plant for making steel or to the original owners of the good health for whatever purposes they wish to put that good health to. What markets or the exchange system actually do is to force cost imposers, here the steel plant, to account for the costs that they impose in production, and thus to impose only those costs that, as we've seen earlier, pay for themselves. Will there be a market for good health? I'll argue that there won't be, because the market for good health will be blocked, as it were. Exchanges will be blocked by high transactions costs, which prevent rights to good health from flowing to their highest valuing owners. And if those high transactions costs prevent exchange, and the plant produces steel anyway, then external costs will be imposed upon the plant's neighbors because they will have suffered costs, they will have contributed their good health to the production of steel, and they will not have been adequately compensated by the firm in order to win their consent for the sacrifice of their good health. And if that happens, an inefficiently large amount of good health will be used to produce steel, precisely because the steel plant is, by hypothesis, able to take the good health of its neighbors without paying for it. And if they can do that, they're almost certain to use more of the good health than they would have used if they'd had to pay for it, and thus they will use an inefficiently large amount of it. And as a result of that, the plant will produce an inefficiently large amount of steel, which it will sell to consumers at an inefficiently low price. So the question before the floor is, what are the sources of the transactions costs that might block transactions between the plant and its neighbors, and thus produce the situation of externality that I've just described? Again, if markets worked well, then good health would be allocated efficiently through free exchange as per the Coase theorem. But if transactions costs are high, then in fact, the good health might be transferred without the opportunity existing for the owners of good health to block the transfer by negotiating a price that the steel plant must pay and giving their consent to the transfer of their property right to good health to the steel plant. So the first question again is what the sources of these costs might be that block these transactions, and secondly, why are these costs greater in the case of the good health input than they are in the case of the ordinary inputs? Those are the questions we'll look at next time.